Welcome to our lab on configuring VTP clients and servers on Catalyst switches. Usual walkthrough in the lab requirements here. Hopefully you've started to get used to how it's all laid out. Look at the topology. Obviously you may set yours up slightly differently with different port numbers. The actual host names and port numbers aren't important as long as you've set up your own home topology in a way that you understand and can map it to my diagrams here. We've got various configuration tasks. I've already set the host names for all my devices, and you know how to do that already because we've covered the hostname command. Just make sure you give the correct names to the correct devices that are plugged in and cabled up in the correct way. You can't just randomly name devices that don't match how it's actually cabled up. Otherwise you'll be configuring the wrong device. So VTP domain Cisco. Switch to show VTP status, and you can see the default is server. So all Cisco switches are left with the default server as a configuration and no domain name. I'm going to change it to VTP mode client, and I do need to add the VTP domain name Cisco. It is case sensitive and it needs to match the VTP server so the client knows it's in the correct domain. Show VTP status and its client, and the VTP domain name is Cisco. I'll just reference back to the configuration tasks to give myself a memory jog, and you can obviously print yours out or check on your screen. So I'm on switch 1, I'll begin my configuration. Interface fast Ethernet 0/1. I've written fast for short, which should work. If it doesn't in the actual exam, just type out fast Ethernet. Switch port mode. What are we looking for? Well, we want a trunk between switches 1 and switches 2. So config T interface is fast Ethernet 0/1 switch port mode trunk, and I've shortened that in the command line there. Show interface is trunk, and I can see my fast Ethernet is in trunking mode. The default is 802.1q, which is in fact the only mode on the newer models of Cisco switches that are shipping. You don't have to worry about ISL. If you've got an older switch, then you'd need to set it to 802.1q. But we needn't worry about that for the CCNA because you'll test it on the new model of switch. So I'm creating my VLAN on the VTP server, and these details and VLANs should be propagated to the client. So 2 VLANs created, show VLAN brief, and you can see we've got 2 VLANs. I've actually got an old configuration left over from a previous lab, so just ignore which ports are where. Show VLAN brief, and you can see the 2 VLANs have been created on the client side, switch number 2. Now obviously I haven't specified which interfaces are going to be in which VLANs. That needs to be done manually. So on switch 1, I'm putting, according to the topology, fast Ethernet 0/2, setting it to switch port mode access, and then I'm putting it into VLAN 10. Normally you'd have a host connected, but just to make it easier, I'm connecting a router. Serves the same purposes for this lab. Show VLAN brief, and I can see fast Ethernet 2. I know I've got another interface in there. Again, that's just an old configuration. Fast Ethernet 2 is in VLAN 10, which is what I want. Switch number 2, our configuration now. Again, fast Ethernet 0/2. Switch port mode access, and then I need to put that into VLAN 10 also. So this will ensure that both of the hosts connected, one on switch 1 and one on switch 2, are both in the same VLAN. They also need to have IP addresses in the same subnet because we're going to be doing a ping from one host to another host just to prove off the configuration. So I'll add the IP address, just want to make sure I've got the correct subnet, otherwise it won't work. And it's 28-bit mask. And now to configure in router 3. This is 10.0.0.3. Same subnet mask, no shut it. I'll just check on the switch. Switch 2. The router 3 is connected to. And you can see the interface has come up. Now I'm going to do a ping. It does take, or it can take, up to 50 seconds for the interface to come up. So what may happen is you could do a ping if you do it quickly on in the lab or early on, and you'll have a 0% success rate, which then may lead you down the troubleshooting path. Just issued a show interfaces trunk. I just wanted to make sure the trunk was up. But everything's working correctly, so I just need to leave it a few more seconds, try the ping again and see if it works. You normally find the first ping fails when the connection is actually up due to an ARP request being sent because the ARP table is empty. Obviously the router needs an ARP entry in order for it to send the packet. So you can see the first ping failed, so it's 4 out of 5 success, or 80%. Do another ping and they'll all work this time. So I've proved off my connection between router 3 and router 1. Proved the VLANs work and the client has taken on the VLAN information from the server. The important command you need to know for switches is show MAC-address-table. This will allow you to start troubleshooting which devices are connected to which port on the switch. Now we just need to go back onto the router and check which is the MAC address for the connected interface, the fast Ethernet interface. Show interface fast Ethernet 0/2. Quickly check the MAC address, or 0/0, sorry. And it ends in 2701, which is all I need to know now to do a check. And you can see it's 2701 is fast Ethernet 0/2. So that's the lab proven off. Thanks for listening.